Hello students, once again here I am with you with my next video. Before I introduce the next chapter, once again I want to remind you something. As you know, lockdown period is going on and I hope you all are doing well and you're utilizing your time in a best way as I said in my previous video. बच्चे ये आपके पास इतना महत्वपूर्ण समय है, इसे नष्ट मत कीजिए. जितना हो सके अपनी रीडिंग हैबिट्स को इम्प्रूव करो. Be with your books, read the books and make notes, improve your reading habits. Again and again I will remind you the same thing. Utilize this time in a best way. So let us begin this new video. This is ICSE class 10th chemistry chapter 8, that is study of compound hydrogen chloride. So this is the part 1 and the topics we are going to do is preparation of hydrogen chloride gas. To prepare hydrogen chloride gas, we will do journal preparation and the laboratory preparation, and also we'll do physical and chemical properties of hydrogen chloride gas. So let us begin the preparation, that is the journal preparation. So we are having two methods to prepare hydrogen gas, and the first is synthesis, which is also known as a direct combination reaction. In this reaction, hydrogen gas is combined with the chloride gas, and see, this reaction takes place in a diffused sunlight and we get product, that is 2 molecules of hydrogen chloride gas. Here we are using diffused sunlight. Why we are not using the direct sunlight? Because in direct sunlight the reaction is explosive. And then again the question is, why the reaction not takes place in the dark? Because in dark there is a negligible reaction will be there, but it can be possible to take this reaction in the dark, but it is only possible with the help of a catalyst, and that catalyst we will use is activated carbon. Then next method for the direct synthesis is when any metal chloride react with sulfuric acid or metal chloride is added to sulfuric acid, will get salt and hydrogen chloride gas. For the reaction, I will say just look at the page number 149 in your book. Write these reactions in your notebook and practice it. Now come to the laboratory preparation of hydrogen chloride gas. For the laboratory preparation, the reactants will be sodium chloride and concentrated sulfuric acid. Now look at the apparatus setup. This is very important because in exam sometimes they do ask, draw the diagram for the laboratory preparation of the hydrogen chloride gas. So in this setup, here I have drawn round bottom flask. Now the reason is why we are using the round bottom flask. Many other beakers are there, but we are using here round bottom flask because we need a high temperature. That's why we are using the round bottom flask. So there is one thistle funnel, and in the round bottom flask we have taken NaCl, that is sodium chloride, and from the thistle funnel, see this is a thistle funnel, concentrated sulfuric acid is introduced from the top, and when the reaction takes place, that is between NaCl and concentrated sulfuric acid, through the delivery tube, in this wolf bottle, the gas will be collected. And before the gas is collected further, it is passed to the concentrated sulfuric acid. Why it is passed to the concentrated sulfuric acid? Just for the purification. That is, gas, we need the gas, it should be dry gas. So to dry it, we have passed it through the concentrated sulfuric acid. Now, and the collection of the gas is done by downward displacement of the air. Why downward displacement of the air? As it is heavier than the air. Which gas? Hydrogen chloride gas is heavier than the air. So it is collected by the downward displacement of the air. It is not collected over the water. Why it is not collected over the water? Because it is highly soluble in water. Now look at the reaction. What the reaction takes place in this experiment. This NaCl, which is already present in the round bottom flask, when the concentrated sulfuric acid is added through the thistle funnel, and the temperature here is more than 200 degrees Celsius. Remember, this reaction is reversible reaction. Will get sodium hydrogen sulfate and the hydrogen chloride gas formed. This reaction takes place in a two-step. This sodium hydrogen sulfate which is formed, it is again reacted with the NaCl at temperature above 200 degrees Celsius, we get sodium sulfate and hydrogen chloride gas. So the overall reaction can be written like this. Two molecules of NaCl when react with the sulfuric acid, that is concentrated sulfuric acid, above temperature 200 degrees Celsius, we get sodium sulfate and hydrogen chloride gas. Now, to identify that the gas jar is full of hydrogen chloride gas, so when the hydrogen chloride gas is exposed to air, it gives white fumes. Why the formation of white fumes takes place? Because hydrogen chloride gas, when it reacts with water vapor present in air, the formation of hydrochloric acid takes place. Because of that, white fumes occur. Now, to know whether the gas jar is full, for this, see in this diagram, HCl gas is there in this jar, gas jar, and if we bring a rod dipped in ammonium hydroxide near its mouth, then you see the dense white fumes will form. There will be a formation of dense white fumes of ammonium chloride produced. It means the gas jar is full of hydrogen chloride gas. See the reaction. Hydrogen chloride gas when reacts with ammonium hydroxide, a rod dipped in ammonium hydroxide, it forms ammonium chloride, and because of this formation of ammonium chloride, dense white fumes occur. And now, what are the precautions to be taken while preparing the hydrogen chloride gas in the laboratory? The temperature should be maintained nearly at 200 degrees Celsius, and the lower end of the thistle funnel should be dipped in concentrated sulfuric acid, and the delivery tube should be dipped in drying agent, that is concentrated sulfuric acid. Now, why the temperature should be maintained 200 degrees Celsius? Or why? What will happen if the temperature is higher than 200 degrees Celsius? First, the fuel is wasted, and second, the apparatus we are using is made up of glass and it may crack at high temperature. And in the reaction, as you know, there is a formation of sodium sulfate which formed hard crust, and it will stick to the glass and it will be very difficult to remove. Now, come to the physical properties. It is a colorless gas with pungent choking smell. It is highly soluble in water and it is heavier than air. Now let us do the experiment to show that it is heavier than air. Now to show that hydrogen chloride gas is heavier than air, see, I am taking this, burning candle is placed in an empty jar, and when this HCl gas a jar full of hydrogen chloride gas is introduced or brought near this burning candle, what will happen? The burning candle gets extinguished. Why? Because HCl gas being heavier occupies the lower portion of the jar. This HCl gas being heavier occupies the lower portion of the jar and forces the air to come out. And this experiment shows that hydrogen chloride gas is heavier than air. And now, the experiment to demonstrate that hydrogen chloride gas is highly soluble. And the name of the experiment is Fountaine Experiment. Now, how this Fountaine Experiment is performed? We'll take a round bottom flask filled with dry hydrogen chloride gas. See, a round bottom flask filled with hydrogen chloride gas. And arrange the apparatus. You see how the apparatus is arranged. It is inverted. And in this round bottom flask, you can see a rubber stopper is fixed and two holes are there. One hole is here, another hole is this. From one hole you can see through one hole a long jet tube is passed. One long jet tube is there, and through the other hole, this other hole, a dropper with few drops of water is there. From this hole, a dropper is introduced, and in this dropper, few drops of water is there. And now this jet is put in a beaker containing blue litmus solution. Now, how to perform the experiment? We'll press this dropper. When we press the dropper, the blue litmus solution present here enters the jet. As this dropper is pressed, the water present in this dropper enter the round bottom flask, and the blue litmus enters the jet tube with a great force and forming a fountain here. And now, what is the reason behind it? How this formation of fountain takes place? Now, as the water enters in this flask from the dropper, axial gas present in this flask gets dissolved in the water which is entered through this dropper, and the pressure inside this flask get lowered, and the outside pressure being higher, it pushes the blue litmus solution through the jet tube, and this blue litmus solution, when enters here in this jar full of hydrogen chloride gas, and here the formation of red fountain takes place because hydrogen chloride gas is acidic in nature.